Example 1, it says express correct the three significant figures 0.003597. Students, when correcting the significant figures, always have this in mind that the 0 is not significant except it is found between other digits. Now looking at this figure, 3 is the first significant figure, 5 is the second significant figure, 9 is the third, and 7 is the fourth. To correct the three significant figures simply means round up or round down the digit after the third significant figure. Because 7 is greater than 5, we'll round up the figure by adding 1 to the third significant figure, which is 9 plus 1 gives 10. 10 is a two-digit number, so write down 0 and add 1 to 5. Hence, 0.003597 to three significant figures is 0.00360. Question number 2. Evaluate 0.064 in bracket raised to power minus 1 over 3. Convert 0.064 to decimal fraction gives 64 over 1000 in bracket raised to power minus 1 over 3. To convert negative power to positive power, invert fraction. Then we have that 64 over 1000 is equivalent to 1000 over 64. Power 1 over 3 is equivalent to square root of 3. Therefore, 1000 over 64 in bracket raised to power 1 over 3 can be written as cube root of 1000 over 64. The cube root of 1000 is 10. The cube root of 64 is 4. Now, 2 divided into 10 gives 5. 2 divided into 4 gives 2. Therefore, the answer is 5 over 2. Example 3. Solve y plus 1 in bracket all over 2 minus 2y minus 1 in bracket all over 3 equals 4. Solution. Step 1. Find the LCM of the denominators. The LCM of the denominators 2 and 3 is 6. Step 2. Multiply both sides by the LCM of the denominator 6. Hence, the equation becomes 6 times y plus 1 in bracket all over 2 minus 6 times 2y minus 1 in bracket all over 3 equals 4 times 6. 2 divided into 6 gives 3. 3 divided into minus 6 gives minus 2. Now we have that 3 times y plus 1 in bracket minus 2 times 2y minus 1 in bracket equals 4 times 6. Step 3. Remove bracket. 3 times y gives 3y. 3 times 1 gives 3. Minus 2 times 2y gives minus 4y. Minus 2 times minus 1 gives plus 2. 4 times 6 gives 24. The equation becomes 3y plus 3 minus 4y plus 2 equals 24. Step 4. Add or subtract like terms. 3y minus 4y gives minus y. 3 plus 2 gives 5. Then we have that minus y plus 5 equals 24. Now subtracting 5 from both sides of the equation, we now have that minus y equals 19. Step 5. Divide both sides of the equation by the coefficient of y. The coefficient of y is minus 1. Minus y divided by minus 1 gives y. 19 divided by minus 1 gives minus 19. Therefore, y is equals to minus 19. Question number 5. Simplify, correct to three significant figures. 27.63 raised to the power 2 minus 12.37 raised to the power 2. Solution. We can subtract the square of a number from the square of another number by applying a method called the difference of two squares. Applying the method, we write that 27 plus 63 minus 12.37 in bracket times 27.63 plus 12.37 in bracket. 27.63 minus 12.37 gives 15.26. 27.63 plus 12.37 gives 40.00. Now 15.26 times 40.00 gives 610.4. To correct to three significant figures, round down the number after the third significant figures. This will give 610 to three significant figures. Solution. The set T is a set of prime numbers. The set M is a set of odd numbers. And the set U is called universal set. It contains elements that are greater than 0, less than 10, or equal to 10. To get the set T prime intersection M prime, first of all, find the elements of the set T prime and the elements of the set M prime. The set T prime contains elements of the universal sets that are not in set T, while the set M prime contains the elements of the universal sets that are not in set M. Having gotten T prime and M prime, the set T prime and M prime contains the element of T prime that are also in M prime. Therefore, the elements of T prime intersection M prime are 4, 6, 8, and 10. To solve the logarithm of 9 to base 3 minus the logarithm of 8 to base 2 all over the logarithm of 9 to base 3. First of all, write number in index form. Then we have that logarithm of 3 raised to the power 2 to base 3 minus logarithm of 2 raised to the power 3 to base 2 all over logarithm of 3 raised to the power 2 to base 3. The rules of logarithm states that the power goes behind to multiply the log. Therefore, we have that 2 log 3 to base 3 minus 3 log 2 to base 2 all over 2 log 3 to base 3. Another rule of logarithm states that the logarithm of a to base a is 1. This implies that the logarithm of 3 to base 3 is 1, and the logarithm of base 2 to base 2 is. Hence, substituting, we have that 2 times 1 minus 3 times 1 all over 2 times 1. 2 times 1 is 2. 3 times 1 is 3. Now we have that 2 minus 3 all over 2. 2 minus 3 gives minus 1. Therefore, the answer is minus 1 over 2. The nth term of an arithmetic progression is given as a plus bracket n minus 1. From the question, the first term a is 6 and the last term l is 14. N is the position of the last term. Recall that the nth term of an AP is equal to the last term of an AP. Hence, substituting into the equation, we have that 14 equals to 6 plus 3 minus 1 in bracket times d. 3 minus 1 gives 2. 2 times d gives 2d. 6 moves to the other hand side and changes to minus. 14 minus 6 gives 8. We write that 8 equals 2d. Dividing both sides of the equation by 2 gives d equals to 4. Having gotten the common difference d, add the common difference d to the first term a to get p. Therefore, p is equals to 6 plus 4. 6 plus 4 is equals to 10. Therefore, p is equals to 10. Solution. If m ratio n equals 2 ratio 1, then m is equals to 2 and n is equals to 1. Substitute the values into the expression 3m squared minus 2n squared all over m squared plus mn. We have that 3 times 2 squared minus 2 times 1 squared all over 2 squared minus 2 times 1. 2 squared gives 4. 4 times 3 gives 12. 1 squared gives 1. 1 times minus 2 gives minus 2. 2 squared gives 4. 2 times 1 gives 2. Now, 12 minus 2 gives 10. 4 plus 2 gives 6. 2 divides into 10 gives 5. 2 divided into 6 gives 3. Therefore, the answer is 5/3.